today's lesson deals with properties of parallelograms. It's nearly identical to 8.2, so that's why I'm only recording one of the two lessons. So this one I think does a much better job in kind of summarizing all the key concepts. So starts off with some of the basics. So what you should be able to do is look at this picture over here and briefly describe what property is being shown in that picture. What property do you see in that picture? Sides. We have side marks. What do we know about these sides? They are congruent, and they are opposite sides. So here's our short little phrase we should write. Opposite sides are congruent. So this is a property of parallelograms that will always be true. On a parallelogram, opposite sides will always be congruent. 8.8. It looks a little bit different. We're not talking about sides anymore. Now we're talking about angles. What can you tell me about angles? Opposite angles are congruent. Good job. So there are two properties, quickly, that you should be able to see from here. And once again, opposite means all the way across from it. All the way across from it, on the other side of the picture. The next little section covers a little quick example. So it looks at parts on a basketball goal. And it says, explain why AD is always parallel to BC. So once again, here's AD. Why is it always going to be parallel to BC? So really focus on that shape. What can you identify on that shape related to the properties we just learned? Okay, we don't say all sides are congruent. We say opposite sides are congruent. Okay, so we could say, since opposite sides are congruent, the shape is a what? Parallelogram. That's why AD is always parallel to BC. Remember the property of a parallelogram? It's in its definition. Opposite sides are always parallel. Up next, we have a couple more theorems you should be familiar with and be able to describe. Now, this one is a little bit different than what we learned on 8.2. It's an additional theorem that we can add on to our list from 8.2. So it doesn't mean that all opposite sides are congruent. It's only one pair of opposite sides are congruent, and only one pair of opposite sides are parallel. So here's the property from that picture. One pair of opposite sides are congruent and parallel. On the next picture, you can see that they have diagonals drawn. And these diagonals are cutting each other into two congruent pieces. So we say diagonals bisect each other. On example 2, you should look at the picture, and you should try to remember which property is demonstrated here. Which property do you see in that picture? One pair of opposite sides are congruent and parallel. Good job. So explain how you know the angles are the same. Well, we know that one pair of opposite sides are congruent and parallel. Therefore, the shape is a what? shape's a parallelogram. And here's the symbol for parallelogram. If you want to shorthand it, the shape is a parallelogram. We know opposite angles are always congruent in a parallelogram. Go down and try these little checkpoints down here. Try checkpoints 1 and 2. All right. In checkpoint number 1, we have a parallelogram. So we can make a quick sketch. Since they didn't provide us one, it's good to make a quick sketch. Angle G is 55, so I can write that in. Angle H is 125. Angle J is 55. It says, what theorem can you use to show that that's a parallelogram? Some of you put a pretty decent answer. What do y'all think it is? You can't say opposite angles are congruent unless you know all angles. Do we know all angles? No, we're missing one. Okay, but we can find it out. So if you can prove what that angle is, then you can use that property. How can you find that missing angle? What's the total of a quadrilateral? 360. So I can do 360 minus the ones there. So minus 55, minus 125, minus another 55. And we're going to find that it's 125. Now we can say opposite angles are congruent. However, there's one theorem that we learned from 8.2 that can go and do this problem without having to find that missing one. It deals with angles that are side by side each other. What was that one? Not corresponding angles, they are different C word. Consecutive. This is the better answer. This is the quicker answer. Consecutive angles are supplementary. So I was fine with this answer, opposite angles are congruent, if you found that missing angle. Only if you found that missing angle. Number 2, it says, what theorem can you use to show the quadrilateral is a parallelogram? Remember, I don't want to see a theorem number. I want that property stated. So what property is being shown there? Not exactly. Not midpoints bisect each other. What was that phrase? Diagonals bisect each other. So write that in. Diagonals bisect each other. And then you're good to go. Example 3 is really straightforward. I have diagonals drawn. They're bisecting each other. To solve for x, what do we need to do? Set them equal to each other. Good job. 5x equals 2x plus 9. Quick solving. This will take probably 2 steps, 3 steps. What do we do first? Yeah, subtract 2x. Get the x's together first. That's a good plan. 5x minus 2x is 3x. Divide by 3. X is 3. Find the value of x that makes it a parallelogram. The value that we need is 3. Up next, they provide us with a very, very useful chart. They show all the properties we need to remember for parallelograms. So what you could do to study this is you could cover up all the words over here, and you should be able to identify the property just by looking at the picture. So this is a great place to study. This will be good. This stuff will guaranteed be on our quiz. It will guaranteed be on our test. You've got to be able to know those properties. Up next, we have one other little problem. And this one is the big problem on my test. This is one worth a lot of points on the test. So this is one you should definitely put a star by, because this is worth a lot of points. So it says show that that shape on that graph is a parallelogram. Now, how many properties have we learned about parallelograms so far? 1, 2, 3, 4. I think 5 is what we just saw in that chart. And it shows a way to do it with the distance formula and slope. But what I want you to remember is this. What is the main definition for a parallelogram? What's that main definition? Think about the word, parallelogram. Yeah, opposite sides are parallel. So write that down real quick. Opposite sides are parallel. How could we prove its definition? How can we prove that the opposite sides on that shape are parallel? What do you need to prove parallel? Slope. So we need to do slope. So write that word real big on this one. We need to do slope to prove parallelogram, and that's the easiest method in my opinion. So we go over here to the picture, and do y'all remember how to do slope? Rise over run. That's good stuff. Rise over run. So rise is how much it goes up or down. If it goes down, it's negative. Up, it's positive. Remember, we're going left to right. So we always run left to right. It's an easy way to do it. So say I want to find the slope of this piece right here. Which point should I start with? K or L? K. Why should I start with K? It's the leftmost point. Remember, we kind of read left to right, so which one's leftmost? K. So I start here. I want to count over to L. So how much do I rise? 2, and I run 2. And we should know that 2 over 2 is just 1. The slope of that piece is just 1. Let's look at its slope across from it. Let's check this one next to see if they're the same. Because if they're not, then we're done. If they're not the same slope, then they're not parallel, and we're done. It's not a parallelogram. So first off, which point should I start with? N, because it's the leftmost. We read left to right. So from N, I go up 2, right 2, and what's that slope? 2 over 2, which simplifies to 1 over 1, or just 1. The next pieces I need to find are over here. Out of these 2 points, which one is my leftmost point? K. So I want to start counting from K. And do I count up or down? This means I'm going to have a negative slope this time. So I'm going to start M equals a negative term. So you need to count how much do we go down to get to that other letter. So we go down 1, 2, 3, 4. I go down 4. So after I go down 4, I go right 2. And so we have negative 4 over 2. Does that simplify? Just negative 2. Double check the one that's opposite from it. Down 1, 2, 3, 4 over 2. Is it the same? Down 4 over 2. Yes, that's also a slope of negative 2. So what do we need to say? What's the last thing we need to say? Opposite sides are parallel. So not only do you have to do the math, but you got to say the property that that math just proved. That's the fastest way to be able to do this type of problem. Once again, find the slopes, prove opposite sides are parallel based on those slopes. That's a property of parallelograms. So this is just one way to prove parallelograms. In this problem, they prove distance formula, meaning the length of 2 sides, and then they find the slope of those 2 sides. So they're proving the property that states one pair of opposite sides are parallel and congruent. Another way you could do it is find the length of all the sides. So you could use distance formula or Pythagorean theorem to find the length and try to prove that opposite sides are congruent. So we're going to be using these other techniques later on other shapes. But my main tip, parallelogram, prove opposite sides are parallel. I think that's the fastest, quickest way.